All right, hi everybody. We are going to go through again just some concepts in this chapter that I think are important to note. Definitions, and I think the concept is rather easy for most of you, but it builds. So tomorrow in 12.6, we'll be using these to do some graphing. This will follow you really through the remainder of your years, even as you go through algebra, algebra 2, trigonometry, even calculus. We will be graphing functions throughout. So what is a function? Sounds like a funny math word. It is a pairing of each number in one set with a number in the second set. I know that may seem a little ominous in your head right now, and I will help make that clear. And basically what this is saying is it's an input-output. The number in the first set is the input, and that's usually, not always, but it's usually an X, and it pairs with one number in the second set called the output, which is a Y. In input-output tables, there is a rule or a pattern. So I made an input-output table here where we have an input days. So say it's the days number 1, 2, 3, 4, 5. That's maybe the number of days you have to feed someone else's pets. And this is the pounds. And each day you need 30 pounds of food for the pets. So the first day, so the number of pounds you need is 30 pounds times the number of days. So this is your rule. So we're doing pounds equals 30 times 1 is 30 pounds. Here, if you feed them for 2 days, 30 times 2 is 60. 30 times 3 is 90. 30 times 4 is 120, and 30 times 5 is 150. This doesn't seem like rocket science, but what I'm trying to show you here is the rule. You could put 125 or a million in there if you wanted to. This acts like a formula, and it's written in terms of P equals. Usually it's written in terms of Y equals 30x, and we'll get to that a little bit later. For this lesson, it doesn't matter if they want you to label it differently. So we're going to try to make an input-output table using the function and rule, and we're going to input the x term is going to be 5, 6, 7, 8, and 9. So I have 4 examples here. You can listen to the first 2, and then I'll just reveal number 3 and 4 when you've tried it. So the first rule, we have y equals x minus 1. And so what you do is you plug in the value of 5 for x. So clearly it is going to be 4. And then you're going to do 6, and it'll be a 5. And then you're going to do a 7, and it will be 6. 8 will be 7, and 9 will be 8. Okay? Not too terribly difficult here. We're going to substitute now these values in for x. So when we have 10 minus 5, you should get a 5. And then 10 minus 6 is 4, 10 minus 7 is 3, 10 minus 8 is 2, and then 10 minus 9 is 1. So what I want you to do is now substitute the values for x. So y equals 5 times 5, 25. You can pause me if you'd like to try this alone, but I'm just going to reveal the whole thing at this point. So check me out on my math there. And then the fourth one, 2x plus 3. The plus 3 at the end adds a little bit of a, it can confuse people with the rule. I'm going to reveal what it should be when you substitute 5 in there. So there you go. Notice there is a notable pattern in each of these. This one goes up by 1, this one goes down by 1, these go up by 5s. These are odd numbers up by 2. So we're going to look at the geometric pattern that you see here. And we are going to devise a rule based on what we see. And I know you can immediately see the pattern. You'll say, well, every square is divided into two pieces. So this is 1 times 2, 2 times 2, 3 times 2, and 4 times 2. You see that in your head, but what you're needing to do is you're needing to organize it into an input-output table. So if we input 1 square, our output in terms of y is 2 triangles. And by the same token, 2 squares is 4 triangles, 3 squares is 6, 4 is 8. So our rule in terms of, you'll see that often, we want in terms of y. This is your output. Usually your output equals your input and then something else done to it. So in this one, x times 2 or 2x equals y. So again, you could put any number in here. You could put 1,123,000 if you wanted to. Doesn't matter. You just need to make sure that you follow the same rule in your input-output. The last thing you're going to need to do is look at an input-output table and write a rule for what you see going on here. So let's see if we input a 9, we get out a 1. If we input an 18, we get out a 2. 27, 3, 36, and 4. What do all of those have in common? And when it says right in terms of y, that means that you have to start with y equals. Y equals what? X, what is done to x? So if I look at each x, x is divided by 9 each and every time. So it would be y equals x divided by 9, or y equals x, you can draw the little division symbol, divided by 9. So this is rather simple, but sometimes figuring out this rule can be a little more complicated, especially when you have to come up with a rule that looks more like this. So some of the more complex problems will have things like this. But generally speaking, you'll be dealing with some of the more simple ones in the assignment today. We'll build on this in 12.6. Have a great lesson.